Given an array of integers, how many pairs of indices I less than j have the same value? The answer isn't obvious when the array grows. Let's find a fast way. You receive an integer array nums. A good pair is any two positions I and j with I less than j and nums I equals nums j. Return the total count of such pairs. The challenge is to compute this efficiently for large inputs. The naive method checks every possible pair with two nested loops, incrementing a counter when values match. This does redundant comparisons. Each element is compared with all later elements, leading to quadratic time, big O of n squared, quadratic time, and constant extra space. The key insight: a good pair is simply a combination of two equal values. If a value appears c times, it contributes c choose two pairs, which is c times c minus 1 divided by 2. So we first count how many times each number occurs using a hash map, then sum the combination formula for each frequency. This single pass builds the map in big O of n time, and a second pass over the distinct keys computes the total in O, k, where k is the number of unique values, overall linear time and linear extra space. Walk through the example. 1, 2, 3, 1, 1, 3. We iterate once, updating frequencies. After the first one, map 1 equals 1. After 2, map 2 equals 1. After 3, map 3 equals 1. Second one makes map 1 equals 2. Third one makes map 1 equals 3. Final 3 makes map 3 equals 2. Now compute pairs. For 1 with count 3 we add 3 asterisk 2 halves equals 3. For 2 with count 1 we add 0. For 3 with count 2 we add 2 asterisk 1 half equals 1. Sum is 4. The algorithm returns 4, matching the 4 equal value pairs in the array. The combination formula guarantees each unordered pair is counted exactly once. You'll spot this pattern when the problem asks for the number of equal value pairs or any combinatorial count based on frequencies. Look for pairs with I less than j and identical elements. Time complexity is big O of n. Space complexity is big O of n for the frequency map. Try the next problem, same pattern. Subscribe for more concise DSA breakdowns.